today what we're going to do is we're going to talk about inverse power functions. And inverse power functions are, we take any equation with a power. So we're going to take f of x equals negative 2x squared, and we're going to calculate its inverse. To calculate the inverse, the first step is to let it equal y instead of the f of x function. And then we let x and y switch places, so x equals negative 2y squared, like that. Now we're going to divide by negative 2, and we get y squared equals negative 1/2 x. So notice that even though I'm dividing by negative 2, I'm making it a fraction because of what's going to be coming next. So what we do then is we take the square root, and we get y equals the square root of negative 1/2 x. And that's the function, that's our inverse function. Okay. So now what we want to do is we want to graph this thing. And to graph it, what we're going to do is we're going to define our domain and range like we always do, and we want to identify our vertex. So when we look at this function, what we should do is we should understand that it's 1 times negative 1/2 x minus h plus k, like that. Okay, and what we're going to do though is we're going to set the centerpiece equal to greater than or equal to 0, right? Because we can't take the square root of a negative. So what we're going to do is we're going to take the negative 1/2 x and force it greater than or equal to 0. Okay, when we do that, we're going to have to multiply by negative 2 over 1. And whenever we multiply or divide by a negative on an inequality symbol, we have to remember to flip the symbol over. This goes to 1, and we get just x. And 0 times any number is 0. So as long as our domain is x is less than or equal to 0, so when we're less than or equal to, and we're going to use interval notation, it should look like that. The other thing is our range. Okay? If we put in all positive numbers, we're going to get all positive. See, we're going to put in negative x. See, it's going to go from 0 to negative infinity. All of these numbers are going to be a negative times a negative. So this number is going to go to positive infinity. So what we want to do is we want to start it at our k value. And k in this equation is 0, right? So we're going to go from 0 to positive infinity on the range. And of course our vertex, we've already said it a couple times, is going to be 0, 0. So what we want to do is we want to start our graph, our table of values at 0. Our function is going to be negative 1/2 x. And we want to record what points come out of that. So if we put in 0, normally we would go +1, +4, and +9. But we want to go into negative infinity. So instead of positive, we want to subtract, subtract, subtract. And that will put in our values 0, -1, -4, and -9. So when we put in 0, we get the square root of 0 is 0. So that's again our starting point. If we put in -1, we get the square root of positive 1/2, which is 1/4. So we get -1, 1/4. If we put in -4, we get the square root of -1 times -4, is going to be the square root of positive 2. So what is that? That's going to be, so we got to ask ourselves, is that a smart number to put in? Wouldn't we be better off putting in like -8? Because if we put in -8, we're going to get half of 8 is 4. So that would be better, so that we can take the square root of the number. So if we put in, so if we take -1/2 times -8, we get the square root of 4, which is 2. So at -8, we get positive 2. That would have been a smarter number to use. So wouldn't it have been smarter in this part then to have used like a 2? So instead of -1, if we would have used -2, what would have happened is we would have got the square root of -1/2, and -2 is the square root of 1, which is 1. So I think it's better that we use smarter numbers. -2 and positive 1 came out of it. And so would it make sense that if we used 18, we would get a 9? So if we use -18, we would get the square root of a -1/2 of -18 is 9, which is 3. So those would be the numbers that we want to plot. So let's clear this, and well, okay, so let's just graph it. And let's see here, we're going to start at 0, 0. And if we go -2, actually we're coming this way. Oops. So we want to get our graph to start about here. We're going to start our graph at 0, 0. But if we go 2, we're at 1. If we go 3, 4, 5, 6, 7, 8, we're at 2. And if we go 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, we're at about 3. So our graph's going to go like that for the inverse power function. Now the thing is we also want to talk about something called the horizontal line test. The horizontal line test. If you'll remember right, when we did when we check to see if something is a function, what we do is we do the vertical line test, and if it doesn't touch the graph in 2 places, then it's a function. Well, what we're going to do here is we're going to do a horizontal line test, and if it passes the horizontal line test, then it's a function. So if we go horizontal to here, you can see that the graph isn't going to double over itself, so it does pass. It is a function. So passes. Okay, so let's try another one. Okay, let's try letter B. And letter B is f of x is equal to the square root of x plus 3, where we want x is greater than or equal to -3. Okay? So if we're going to do the inverse of this function, what we're going to do is we're going to say that y equals the square root of x plus 3. And then we're going to square both sides. Well, sorry, we want to let x and y change places. Now we want to square both sides. And we get x squared equals y plus 3. We would then subtract 3. So you get y equals x squared minus 3. And that would be our inverse function, y equals x squared minus 3. Now the interesting thing here is that we wanted x to be greater than or equal to negative 3. So if we look at the original function, if we're going to graph y is equal to the square root of x plus 3, and x is greater than or equal to negative 3, then what's happening is we're only taking part of the graph, right? So if we go to x is greater than or equal to negative 3, we're going to start here, and our graph is going to look something like this. Well, with an inverse function, what we're really doing is we're reflecting these graphs over the equation y equals x. So what we want to do is we want our graph to start perfectly opposite it, right? At a right angle to this line, for it to be the inverse graph. So what we're going to want it to do is we're going to want it to come this way, right? Makes sense? Okay, so we only want to concern ourselves with we only want to concern ourselves with the positive, that side of the graph, of this graph, of the second line, okay, of the inverse function. So we only want to be on that side. We don't want to do this other side. Okay, so that's what we want to do, is we want to get all of the values for x is greater than or equal to 0 will give us that other side. Okay, so let's do that. And we want to make a table of values. And so we are going to start at 0. And we're going to go up 1, 2, and 3. If we put in 0, squared minus 3 is negative 3. That is our starting point. If we put in 1 squared minus 3, we get negative 2. If we put in 2 squared minus 3, we get 1. And if we put in 3 squared minus 3, we get 9 minus 3 is 6. So this point here, so that should be 3, 6. And you can see that I already drew it, but if you go over 1, you'd be at minus 2. If you go over 2, you'd be at minus 1. And if you go over 3, you would be at positive 1. And you can see that's our graph there. So that is the inverse of the original function, y equals the square root of x plus 3. All right, so let's try the last one. Board's looking pretty dirty. But we get f of x is equal to x squared plus 4. And we want only the values of x that are less than or equal to 0. So what we do is we're going to first solve for our inverse. So remember, we let it y equals x squared plus 4. We change f of x to y. And then we exchange x and y's position. And then we solve for y, so we're going to subtract 4. And we get y squared equals x minus 4. And then we take the square root, so that y equals the square root of x minus 4. Okay. So the next thing we want to do is we want to graph this thing. Well, first we want to graph this for the values of x greater than or equal to 0, and we want to see what happens to the graph. So if or x is less than 0. If x is 0, we get positive 4. If x is, let's see, 1. Actually, we want less than, right? So we want negative 1. Negative 1 squared is 1 plus 4 is 5. And then it would go up to, if we go to 2, we're going to go up 4. And so this would be the left side of the graph. Now the thing is because we want to reflect it, the idea behind an inverse function is that the x and y values switch places. So what I was trying to say in the last problem is because this address is 0, 4, its inverse's vertex is going to change places. So if this is 0 and this is 4, what's going to happen is this is going to be 4 and this is going to be 0. So they're going to switch places. And we're going to place a point. And then we want to go away from, see how this is going away from the center line, from the line of reflection? And we went up 1 over 1, and then we went up 1, 2, 3, 4, and we went down 2, and so that would be the inverse reflection and the graph of this equation. And that's really all you got to do. That's it. So, see you in class.